Okay, so let's have a look at different types of data and graphs that you would use to plot these different types of data. So we're going to look at two types. We're going to look at categorical data and numerical data. Now, categorical data is basically data that are not numbers. So things like hair color or car color or types of music, things like that are non-numerical. So they're divided into two types, ordinal and nominal data. So ordinal data is categorical data that you can put in some kind of order. So for example, grades in an exam, you can get an A, a B, or a C, a D, and so on. So they can be put in order. Or something like stress levels or blood pressure. You can say that someone's blood pressure is low, medium, or high. You can say that someone's stress levels are low, medium, high. So they would be ordinal categorical data. Nominal data then would be data that you can't put in any kind of order. So for example, hair color or color of cars, types of music, things like that, they would be nominal data. Now the other type of data we have over here is numerical data, and that's divided into discrete and continuous. Discrete data would be things like, let's say, if you're counting the number of people who pass by, you would say one person passes by, then two, then three, then four. So there's nothing in between 3 and 4. There's no possibility of counting the number of people going by as somewhere in between 3 and 4. So that would be discrete data. Or shoe size, shoe sizes go up in usually ones or 1.5s, or halves rather. So you can have a shoe size 1, shoe size 1.5, shoe size 2, but nothing in between. Continuous data then would be numerical data where there's an infinite number of numbers in between any two numbers. So for example, let's say we take heights of people. Let's say someone is 1.5 meters tall, and someone else, let's say, is 1.6 meters tall. Well, there are an infinite number of heights, possible heights in between those two. You could have someone who is 1.51 or 1.511 or 1.51111 meters tall and so on. So this would be classed as continuous. Okay, so let's have a look at the types of graphs that you can draw representing those types of data. The first one I'm going to have a look at is a line plot. So a line plot, or some people call them dot plots. Okay, so let's take, for example, if you're looking at a certain number of different colored cars, let's say. So let's say you got 2 red cars. Let's say we got 4 blue ones. Let's say 1 black, and let's say 3 gray cars. And you want to represent that on a line plot or a dot plot. So generally what you would do is you would just draw a line like this, put in your colors here. So let's say red will go in here, let's say blue here, black here, and we'll put gray here. And the way it works is that you would put one dot or one little X for each red car, each blue car, each black car, and each gray car. So we have 2 red cars, so we would put in, let's say, an X here and an X here. So that represents 2 red cars. 4 blue cars would be just 1, 2, 3, 4. 1 black car, just 1 X, and then 3 gray cars, so we've got 1, 2, 3. So we would put a title in as well. Let's say colors of cars, something like that. And these dots then represent the number of each colored car. Now, line plots are used generally for small amounts of data. So you don't want to have, let's say, 100 or 1,000 or 10,000 grey cars. It's going to take you quite a while, and it's going to be a very big graph. So usually line plots or dot plots are used for small amounts of data, and so we're going to be talking about small quantities. And also we're going to talk about using it for categorical data. So it'll be used for categorical data, or you can also use it for discrete numerical data either. So that's your line plot or dot plot. Let's have a look at another one then. We're going to have a look at bar charts. Okay, bar charts. And bar charts also are used for categorical data. Or discrete numerical data. So we're going to talk about categorical data or discrete numerical data. Now, bar charts with the line plots, we can, you can use line plots to draw data or represent data that's categorical or discrete numerical, but usually you would only use line plots or dot plots for when you've got small amounts of data. Bar charts, on the other hand, can be used for large amounts of data. So let's take an example, and we'll draw one. So let's take, for example, people traveling to work every day. What kind of transport do they use? So we'll talk about the mode of transport. So let's say bicycle. We'll also say car. They can walk. They can go by bus. And let's put in train as well. So the number of people we're going to put here, or the frequency. Let's say 3 people travel by bike, 10 people by car. Let's say 7 walk and 7 go by bus, and we'll say 3 people go by train. So this is our frequency table here. This is our frequency table here. So we're going to represent this on a bar chart. So I'm going to do this freehand, but when you're doing this, use a ruler to do it accurately, or do it neatly anyway. So we're going to draw our y-axis here. Whoops, a little bit. Let's do that again. So we're going to draw a line down here to represent the y-axis, and this is our x-axis here. So what we're going to do is put our categories along here. I might just make that a little bit longer. So we're going to start here with bicycle. So we're going to put our first bar here. Second one then is car. Then we've got walking. We have bus. And we have train. So these are our modes of transport here. So normally as well, by the way, you would put a title in here. So we'll call this modes of transport. So this is our title. Now you would put the frequency up along here, so we can call it frequency, or number, you can use that either. Number of people. So let's say bicycle. Let's see what we've got here is the maximum we've got is 10. So we could go up in ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 here. So So the first one is bicycle here. So you would come out from the y-axis and you would draw your first bar, and that goes up to 3 here. So we're going to do, let me do it in a different color here. So let's say we start here. We're going to go up to 3 and then down. You can shade these in if you like. Now you come out about the same distance again, and we're going to do car. So let's see how many we got. We got 10 here for car, so we're going to go all the way up here to the top. Cross and down again. Whoops. Okay, again, use a ruler here, so there's our car. So again, come out the same distance. These bars should, by the way, be the same width. So we have 7 who walk, so we're going to go up as far as 7. So we're going to come up to 7, cross and down again. So this is walking, and the same for bus. We've got 7 people who travel to work by bus, so we're going to go up the same height. Cross and down. So bus, and finally we've got train. We've got 3 people who travel by train, so we're just going to go up to 3. Cross and down. Okay, and that's it. That's really our bar chart. Now, I haven't done it with a ruler here. You guys need to do it with a ruler. These bars should be the same width and the same distance. These distances here should all be the same distances apart. Okay. You should have a title here, and you should have a label here for your y-axis, and you should have each category here along on the x-axis. And that's really it for your bar chart. Now you can do these, this is a vertical bar chart, you can do these horizontally as well. So in other words, you would put these categories here on the y-axis, you'd put the frequency or the number along the x-axis. So it would be just this entire graph flipped around this way. So it would look, I'm not going to draw it all again, but you would basically get something like this, where the bars would come out this way. So it depends on your preference, really. Okay, so you can do another type of graph, which is a kind of a compound graph, where you would have something like this. Again, you would have your y and your x-axis. You would have, we'll just do 2 bars. So we'll have a bar like this, and we'll put in another bar here. Let's say the same height. And let's say 2 candidates running in an election. Let's say this is candidate number 1 and this is candidate number 2. And let's say you want to know who's going to vote for each candidate. So let's say we have one, let's say male candidate and one female candidate here. And you're going to ask people who you're going to vote for. So maybe you would ask men and women. Maybe you would go out and take a sample of maybe 500 men and 500 women and ask them who they're going to vote for. So this is the male candidate here, and let's say you find that this percentage here of men will vote for the male candidate, and let's say this percentage here represents the number of men who would vote for the female candidate. So you'd have a little key here as well somewhere. We'll put it here. You would just say these are male voters, and this would represent then female voters. So, and then this could be percentage here. Maybe this is 100% of the people you ask. So you can see here, this might be 50% here. So you're looking at about maybe 60% of men will vote for the male candidate and 40% vote for the female candidate. You can see here that fewer men maybe would vote for the female candidate. Not necessarily the case, but this is just an example. So you can get these kind of compound bar charts as well. Okay, let's move on to the next type of chart, and that is just called a pie chart. Okay, so pie chart, let's use the same example that I used earlier. Let's talk about modes of transport here. So let's talk about modes of transport. So we're looking at the mode again, the mode of transport, and the number of people. The number of people. So we talked about a bicycle. We had a car. We had people walking. We had a bus. And we had a train. So we had 3 people, 10 people, 7 people, 7 people, and 3 people. So this was our frequency table here. Now we want to draw a pie chart to represent this. So what you would have to do is, because we're talking about a pie chart here, we're talking about a total number of 360 degrees here. So you need to work out the sector of the circle that represents a bicycle, a sector of the circle that represents cars, walking, buses, and trains. So in order to do that, what you need to do here is just add up the total here. We have a total of 13, 20, 27. We have 30 here in total when we add these up. So the fraction of people who go by bicycle would be 3 out of 30. 3 out of 30. So that's the fraction of people who travel to work by bike. So we need to work out the angle that we need to represent we need to work out the angle that we need that to represent in our pie chart. So we're going to multiply that by 360 degrees. You know, when you do that, you get 36 degrees. So we need to make an angle of 36 degrees, and that will represent people who travel to work by bicycle. By car, we're looking at 10 people. So it's going to be 10 over 30. That's the fraction of people. 1/3 people travel to work by car. So when you do that, you just get, by 360, you just get 120 degrees. We have 7 people who walk, so we're looking at 7 over 30. Multiply that by 360 degrees. That will give us 84 degrees. And that's also the same for bus. And finally we have 3 here again. We know that's 36 degrees. So we need to just represent these angles on our pie chart. You guys need to use a compass, a ruler, and a protractor to draw your pie chart. I'm going to do it freehand here. So the first thing you need to do is just draw a circle. Let's try and draw a better one than that. So we're going to draw our circle. And your center is going to be here. So the first thing you do is draw a radius. Draw it over here like this. Okay, so we know that we've got to represent bicycles first, and we can see that bicycles are going to be 36 degrees. So you get your protractor, put it along here, measure 36 degrees. It's going to be, you know, something like this. Put in the angle, 36 degrees, and bicycles here. I put in bike here. Okay, so that's our bicycle. The second thing we need to do is just represent cars. We can see cars 120 degrees. So again, put your protractor, you need to put your protractor along here and measure 120 degrees. Well, 90 degrees will be there. 120 is going to be along here somewhere. So let's see if we can do that. It's going to be somewhere around here, let's say. So that's 120 degrees, and that represents cars. Third one then was 7, so that was 84 degrees, so that's going to be, let's say, somewhere here. So that's 84 degrees. And that represents people who walk. And we need another one of those, so it's going to be, let's say, around there. So that's another 84 degrees. And that's people who go by bus. And then finally, this here should be 36 degrees, and that represents people who go by train. So again, this is modes of transport. Okay, so that would be your title here for this particular pie chart. So make sure you put a title in, and make sure you put the angles in, and make sure you put the labels in each sector as well. Now, if you were just given the pie chart and not the raw data, all you've really got here is the proportion of people who go by car, walk, bus, train, and bike. You know, you won't be able to work out the actual numbers of people. You'd need more information to do that. Now, we started with the numbers, so we do know how many people in total we sampled and how many people from that sample went by bike, car, walk, train, and bus. That's our pie chart, and again, our pie chart is really just, it's used for categorical data. Categorical data. And as I say, if you're just given the pie chart, you're not going to be able to work out quantities. It'll just show you the proportions of people. Now, the next thing I'm going to have a look at is what's called a stem and leaf plot. Stem and leaf graph or plot. So stem and leaf plots are used for small amounts of data, and it's normally used for numerical data, or you can use it for continuous data, that has been rounded. So if it's been rounded to the nearest whole number, you can use continuous data. So an example of this would just be, for example, if you take people's pulse rates before and after exercise. So we look at pulse rates before and after exercise. So this is going to be our stem and leaf plot. So the way you do this is you draw a column here down the middle. We'll do a back-to-back one. So this is going to be our stem. This is our stem here. And then out here you've got the leaves. So we're going to have one on the left, one on the right. So on the left here we're going to say this is before exercise, and out here then we're going to have after exercise. So normally what you do, if you have the raw data, what you would need to do is get the raw data and rank it, or put it in order first from lowest to highest, and then put it into your stem and leaf plot. So I'm going to look at pulse rates between, in the 60s up to 140s. So I'm going to look at 6, 7, 8, 9, 10, 11, 12, 13, and 14. So let's say we had a 68. Let's say we had another 68, we had another 68, and then we had a 69. So this would represent someone's pulse rate, and it was 68. This one here would be another 68, this would be another 68, and this would be a 69. Now we'll do the 7. So let's say we had a 70, 71, a 71, 74, let's say a 6, and let's say an 8 here. Okay, so here we're looking at 70, 71, 71, 74, 76, 76, 78. So 8, let's say we have a 2, a 6, let's say an 8 and an 8. Under 9, let's say 0 and 6. 10, let's say we have, this is 104. This would represent 104 here. 11, let's just put in a 0 here. And let's say that's it for before before exercise. So these are all the people. So we sampled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 people. So now we're going to look at those 19 people after exercise. So this is before, this is after. So let's see. Let's say, well, their pulse rate is going to go up. So let's say we start here at 80. Let's say 6, 7. Let's put in an 8 and an 8. Under 90, let's put in a 0, 2, 2, 4, 5. Let's put in an 8, a 9, and a 9. Under 10 here, which is actually 100, let's say we put in someone who has a pulse rate of 100, 104, and let's put in another 104. This is 11 here, so that means we put in an 8 here, so that would be 111, so 118 I should say. Someone has a pulse rate of 118. Under 12 here, let's say we put in 2 4s, so that would be 124 and 124. And someone here, we'll put one person up here, let's say 146. So this is a back-to-back stem and leaf plot for people's pulse rates before and after exercise. Now normally as well you would put in a key here on either side, so let's do that. The key just tells the person looking at it what these numbers actually mean. So normally what you would do is you would put in your key, the word key here, and then pick one of these numbers. Let's say 86. We'll say 8 with a line and then 6 equals 86. Just tells people that it's the number 86 rather than 8.6. Let's do one on this side as well. So we're going to look at key again, and let's pick one of these big ones, 100, and let's say 11. Well, we'll actually do it the other way this time. We'll pick the 10 and the 4 actually. So we have the 10 here, the line here, and we have the 4 here, and that represents 104. So that just tells the person looking at this what these numbers actually mean. And that's really it for a stem and leaf plot. The last thing I'm going to look at is what's called a histogram. I'm just running out of room here now, but let's see, we should fit it in here, I think. Let's look at histograms. Histograms. Now, histograms are used for continuous numerical or numerical continuous data. So it's very similar to the bar chart, except the bars are all stuck together. So if we look at, let's say something like this, times, and let's say the number of people here. So this could be the times that people, I don't know, finish a race or finish a question in an exam or something like that. So times in, let's say, minutes. And let's go from 0 to 3 minutes, from 3 to 6, from 6 to 9, and from 9 to 12. And let's say we have 4 people who did it in under 3 minutes. We have 11 people who did it between 3 and 6 minutes, 20 people who did it between 6 and 9 minutes, and 15 people who did it between 9 and 12 minutes. Normally there would be a note with this as well to say that 0 to 3, for example, 0 to 3 means, or what it, it includes everything up to 3 minutes, from 0 to 3, but not 3. Or you could say, in other words, does not include 3 minutes. So if someone finished in exactly 3 minutes, they would go into the second one here. So this would be 3 to 6, but doesn't include 6. This would be 6 to 9, but doesn't include 9. This would be 9 to 12. So to draw this particular histogram, again, you would put in a title. So something like, I don't know, time to answer a question in an exam, something like that. you would again draw your X and Y axis. So you would have your X and Y axis here. We have our frequency up along here, so the number of people, number of people here, and we are going up to 20. So let's say 5, 10, 15, 20. We would have something like this: 5, 10, 15, and 20 people. Now along here we have our groups. This thing here, by the way, is called a grouped frequency table, because we've grouped our data, we've grouped our people here into groups of times. So looking at this table, we don't know exactly what time each of these people here finished the question. We just know that the 4 of them finished them somewhere between 0 and 3 seconds. So we don't exactly know what time each of them finished the question. So to draw this then, we would start here, we would go out here, let's say out to here. This would be 0 to 3. You go out the same distance again, so this would be 3 to 6. Go out the same distance again, so this would be 6 to 9. And go out again, this would be 9 to 12. So this would be 0, 0 to 3. This would be 3 to 6. This would be 6 to 9. And this would be 9 to 12. So drawing the graph then, our first group here is from 0 to 3, and there were 4 people. So it would be about here, so you just come out. Let's do it in a different color here again. So let's just come out to here, so we come over and down. Second one was 11, from 3 to 6, so we need to go up to 11. So you just come up here to 11, over and down. Now we've got 6 to 9 was 20, so we've got to go all the way up here to 20. Across to 9, and then back down again here. And then the last one was 15, so we're looking at about here and down. So again, you know, use rulers so that it's nice and neat again. So you can shade these in as well if you like. But you can see here that all the bars are stuck together, unlike the bar chart where they're all separate. So just put a title in here or a label in here as well. This would be times, and put in the units as well in minutes. Now in this particular case, and for our course here, we're just going to look at these bars being equal widths. So 0 to 3, that's 3 units wide, 3 to 6, 3 units wide, 6 to 9, 3 units wide, 9 to 12, 3 units wide. In reality, these bars can be different widths, but I'm not going to go into that in this video. But for our course anyway, we're just going to look at bars, as I say, that are equal widths. So that's really it for types of data and how you would graph them.